even just that mechanism alone probably is enough to kind of spark a bit of innovation, I would have thought, in the Go community, because who knows what you could build. I mean, well, a file watcher was one thing that I thought of there, but I bet there's loads of things you can do if only you could get an insight into what's really going on in the kernel.
The possibilities are endless.
Getting quite excited about it.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Get $100 in credit at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com. And get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. This episode is brought to you by Teleport. Teleport lets engineers operate as if all cloud computing resources they have access to are in the same room with them. SSO allows discovery and instant access to all layers of your tech stack, behind NAT, across clouds, data centers, or on the edge. I have Ev Consovoy here with me, co-founder and CEO of Teleport. Ev, help me understand industry best practices and how Teleport Access Plane gives engineers unified access in the most secure way possible.
So the industry best practice for remote access means that the access needs to be identity-based, which means that you're logging in as yourself, you're not sharing credentials from anybody. And the best way to implement this is certificates. It also means that you need to have unified audit for all the different actions. With all these difficulties that you would experience configuring everything you have, every server, every cluster, with certificate-based authentication and authorization, that's the state of the world today, that you have to do it. But if you are using Teleport, that creates a single endpoint. It's a multi-protocol proxy that natively speaks all of these different protocols that you're using. It makes you to go through SSO, single sign-on, and then it transparently allows you to receive certificates for all of your cloud resources. And the beauty of certificates is that they have your identity encoded and they also expire. So when the day is over, you go home, your access is automatically revoked. And that's what Teleport allows you to do. So it allows engineers to enjoy the superpowers of accessing all of cloud computing resources as if they were in the same room with them. That's why it's called Teleport. And at the same time, when the day is over, the access is automatically revoked. That's the beauty of Teleport.
All right, you can try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Are you repping your favorite Go podcast with a comfy t-shirt? Buy one today at gotime.fm/merch. All right, we have an awesome episode for you. Let's get into it. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer and today we're talking about eBPF. eBPF is a technology that allows you to run programs safely in a sandbox without having to change kernel sort code or install modules or anything like that. And this has been sort of typically the perfect place really for solving problems like networking, security, or observability. Because, of course, the kernel controls everything, it can see everything. So it's kind of perfect, really. But because it is such a core component, it means it's actually difficult to change. If you think about your own code, if you've got a core service or something that is a dependency for lots of other systems, you can see where that gets to be quite difficult to change. And, when you can't change something, you can't innovate there. So that was typically the story, really, for changing the kernel would be quite not really an option until eBPF comes along, apparently, to change the rules. Let's find out more about it, because we're doing an episode on it right now. And joining me on this episode, I've got Derek Parker. Hello, Derek.
Hello.
Derek, you created Delve, didn't you? You only went and created Delve.
Yes, that's correct.
Yeah, and you are a senior software engineer at Red Hat, apparently.
Yep, that's right.
Very cool. Welcome to Go Time. We're also joined by Grant Seltzer. Grant is on the open source engineering team at Aqua Security.
Yep.
And lives in Brooklyn in New York City. What a cool place to live. Thanks for joining us, Grant.
Thank you for having me.
No, it's an honor. The honor is all ours. Mine, 50% mine, and 50% Johnny Borsico is also here. Hello, Johnny.
Hello, mate. I'm here to ask all the silly questions about eBPF.
Oh, good, because that'll save me from doing it.
I'll make you look good. I'll just ask all the...
Yeah. I mean, I just wrote that intro from Wikipedia, mate. Rest of it, I'm an imposter today. I don't mind these episodes where I'm kind of the imposter. Like, I don't really know the subject because I really then get to explore it. And I always learn so much, especially when we have guests such as these esteemed gentlemen. So who wants to kind of give us a bit of a background on eBPF? Where did it come from? And what really is it?
eBPF, like you said, it's a technology that lets you write small snippets of code and then put those into the Linux kernel at strategic points that they'll be run in response to certain hooks. So you could kind of think of it in the same way as registering a webhook for a web service. In the same way, you could do that for your actual system. So the things that you can have these small, you could think of them as scripts. Things that you could have them respond to include like a kernel function being called, like something happening within the Linux kernel source code. You could attach them to functions, things like that. You could attach these BPF programs to network sockets and have them respond to packets coming in or out. You could attach them to user space functions. So if you have a compiled Go program that you're running, some service, even if it's a long-running service, you can attach them to it's not the actual source code that you're attaching them to, but the symbols inside your compiled binary that correspond to the actual functions. You could have eBPF programs respond to that. That's something Derek, I'm sure, can talk about.
Wait, I told you I was going to ask the silly things. Let me say what you just said, but in a much simpler way for me.
Sure.
eBPF is like, so the kernel is like HTML and eBPF is like your JavaScript. So that when somebody clicks a button on your HTML, your JavaScript can react to that event happening.
Exactly. So that's one way that a lot of people, I think the quote originated from Brendan Gregg, but that's the typical way that people like to explain BPF. It's a very good analogy to make.
Is that a purely observatory thing? Can you only listen to things or can you change things?
No, you could actually change things and you could make responses. You could really, there are certainly limitations because safety is certainly a concern. You don't want to just be able to put anything into your running operating system, especially in production. But yeah, there's a lot you could do. You can take action. You could prevent a process from occurring. In the case of like routing networks, you can reroute packets as you please.
I've got all kinds of spidey senses going off right now, but we'll get to that.
Yeah, I've seen like pure eBPF based load balancing and that kind of stuff, which I think is really cool and really interesting. And the other kind of interesting thing about like the eBPF programs in and of themselves is like, so you write them in kind of like essentially C, but it's like it's kind of like a stripped down version of C. So like instead of fighting like a typical C compiler, you have to fight like the BTF verifier or whatever, which like complains like you can't have loops in your BPF programs. You have to be really careful with how much stack space you allocate because there's stringent requirements there because it has to be safe as it's running in the kernel, even though it's sandbox. The program still has to terminate. So you can't have like loops and things like that where the verifier can't verify that the program's actually going to terminate and stuff. So there's some like interesting things that you have to do in that aspect when you're writing the programs to kind of get around some of these limitations.
Are these things done with the permission of the kernel? Like, was this something that is explicitly allowed, or is this something that's kind of being done to the kernel?
Well, BPF definitely exists within the kernel. It's a virtual machine that's part of the Linux kernel. It ships within everything. In terms of loading the actual programs and what those programs can do, there is a permissioning scheme behind it. Like you have to have root access or a particular capability in the process that's loading the BPF program.
Right. So you can't just do this on any kind of to any kernel. This is a technology that is explicitly supported.
Correct. You couldn't do it on Mac OS.
Yeah.
It's specific to Linux. And all Linux distributions are shipping with it. There's also something that I really can't speak intelligently about, but there is an effort within Microsoft to port BPF to Windows.
Yeah, I've actually heard a lot about that too, but I don't use Windows to develop on, so I don't know like the state of it. But I thought that it was just cool because it's cool to see like some of the innovations that come out of Linux kind of propagate to other places. Like I wish we could do like more native like containerization stuff on Mac OS instead of having to like, oh, let's just real quick install Linux VM and pretend that we're doing container stuff on Mac OS, but we're really not. I think it's cool for Microsoft to, if they actually are adopting that kind of stuff like in kernel instead of, I don't know if it's like actually properly in kernel or if they're also doing like behind the scenes like WSL real quick and we'll just shoot all your eBPF stuff over there.
I do think it's user space based right now, but I don't want to mischaracterize it, but I think you are correct. But I think it would be kind of cool for like anti-cheat software to be able to ship if you're gaming on Windows and the company that makes the game wants to prevent hackers from cheating in the game to be able to ship BPF programs that detect new cheats that have been found in the wild. I think that's a very cool application of it.
It's like what is it called? Punk Buster or whatever is like is one of the like anti-cheats for like some of the big games like Punk Buster eBPF edition.
Yeah, there you go.
So I'm trying to visualize sort of the concept, right, between user space and kernel space and everything else. So like, and for those who really are still trying to wrap their heads around this, generally speaking, when you and I write a program, say not favorite programming language, like Go, for example, we're writing sort of those user space programs that when they need to do something, basically at sort of the operating system level, they make a system call, say, hey, I want to open a file, right? So for us, the developers, we're using, the sort of the standard library in Go, saying, hey, can I please open up this file because I want to read content or whatever it is. So that's a system call that then gets handled and basically all the sort of operating system level stuff gets done for us. And then we get back that result. But we're still, all that happens in user space, right? So what we're talking about here is actually the ability to write programs that run in kernel space, right? So going that level basically deeper, right? To actually listen and react to and potentially change what the actual kernel is doing.
Yeah, precisely. Yeah. So you get a lot of advantage to that. Like, so let's take the example of a system call where, like, I guess the flow of events is that your Go program tries to write to a file. Under the hood, the Go standard library is using the write system call. Leading up to the system call, your Go program puts whatever information it needs to in the correct registers, and then it executes a system call instruction, and then the kernel takes over, executes the system call, returns back to user space with, hey, we were able to write to that file or whatnot. In the eBPF world, you can write an eBPF program that is triggered by system calls. So if you were to have an eBPF program that is triggered every time the write system call is called, so adding to that original flow of events, the Go program sets up the system call, it executes it. Right before it executes it, the eBPF program runs. It can look at all of the arguments that were passed to that system call. It could do whatever it wants. And then once it's finished, the system call executes, then returns back to user space, et cetera. And that's the BPF side is completely invisible to the application that actually triggered it.
Interesting.
So does it run as a kind of background to the main things that are going on, or is it a blocking code? How does it actually run when it sees a particular call has happened?
So like in the case of like a probe attached to like a function or something like that, it's blocking. So for that moment of time, like the execution of the program that invoked or triggered the probe will be stopped so that the eBPF program can do kind of any kind of inspection or whatever that it needs, which is also why, like, for the context of like tracing, this is kind of what got me interested in eBPF was the combination of the two last subjects we were talking about, which is like the overhead of system calls and just the overhead of tracing in general. So a similar thing would happen. So the reason why I got interested in it was because I wanted to make Delves, the tracing backend, more performant, like have less overhead, so that maybe you could use it like in a production context if you wanted to. I did a tweet a while back when I first started working on it of like the overhead added. So like I had a program that ran in like some odd number of microseconds. And then with eBPF based tracing on top of it, it went from like, I don't know, maybe like 20 microseconds to like 300 or 400 microseconds or something like that, which sounds like a significant amount of overhead, but like we're talking microseconds. Mm-hmm. And then I timed it using the ptrace based tracing that Delve had been using prior, and it bumped up to like 2.3 seconds. So you go from microseconds to actual seconds, which is like, you can't have that kind of overhead if you're tracing something in production. So that was kind of what got me interested in it. Having these really like small targeted programs that can be called as a result of something that don't do context switching between kernel and user space, and stop the program for as little time as possible, and really get kind of performant, detailed, but also ad hoc tracing. The other kind of difficult thing was like making it ad hoc. So a lot of times when people write eBPF programs, they're very, very targeted. Like you already know when you're writing the function what corresponding function it's going to be attached to, like what kernel function or whatever, like you generally already know or whatever. So you kind of know the arguments to expect and things like that. But in the case of Delve and what I was doing with eBPF, I was kind of abusing it a little bit to try to do like, just, I want to attach this probe to a completely arbitrary function where I don't know how many arguments or return arguments it has. I know nothing about it, but I want to get all the information out of it. How do I do that? And so that opened up a lot of questions of how to write a generic eBPF program and how to communicate between that program and Delve, right? Like communicate between kernel space and user space in a way that also wouldn't introduce back the slowness that I was trying to get rid of.
Mm. You mentioned earlier, basically you're using sort of a constrained C, right? There's certain things that are not permitted, obviously for performance reasons and other things. So what's the development workflow for this? Like, if I want to use eBPF, do I have to use C or do we have wrappers, SDKs? Like, what's the development workflow like?
So the eBPF program itself, so I think from a high level, it's, well, not just to visualize it, this is how it is, where you have two sides. You have the eBPF programs themselves, and then you have the user space program that loads them into the kernel and listens for feedback, and essentially the agent that interacts with the BPF programs themselves. So on the BPF side, I only have experience with doing it in C. I think that there was talk about a library where you can write the actual BPF programs in Rust, because the backend to it is LLVM. LLVM kind of controls the specification for the eBPF bytecode. But similar to the Windows BPF, I really don't know anything about it and don't want to talk about it. Plus, Rust is like the competing language, so we can't talk about it. So you write the BPF program in C. So for the most part, you're just stringing together these helper functions that are defined in the BPF world. Like they're BPF helper functions that are defined in header files that you have to use. So they're really not too complex. If you're a Go developer, it wouldn't take long for you to pick that up, especially looking at examples. And there's a lot of guides for getting into it. And on the user space side, you can write a program in, there's even more options there. So there's a C standard library for doing that. That's called libbpf. Then there's a project that you may have heard of called BCC. You shouldn't use that though, but that essentially lets you use like either Python, or there's a Go version of it. There's even an old unmaintained Lua version, Rust, and certainly you can do Go. So with Go, there's also a bunch of different libraries that you can use on the user space side. I'm partial to one called libbpf Go, which is a wrapper around libbpf, the one I just mentioned. There's also a standard, or rather a Go native implementation that doesn't wrap around libbpf. That's part of the Cilium project, but I maintain libbpf Go and use it for projects that I also help maintain. So I'm partial to that.
Slightly biased.
Yeah. I'll be transparent about that.
So obviously you mentioned that this is sort of a Linux only kind of thing, aside from sort of whatever's in progress for Windows. So if I was on a Mac and I needed to write these kinds of programs, I'd have to use some sort of virtual machine, like to be able to test and run these things.
Yeah. For now.
I remember there's like dtrace and stuff from back in the day on like for Darwin kernels and stuff like that.
Yeah, macOS has I don't remember the exact name, but some type of security framework with a recent version of macOS that is comparable, but there's no interoperability there.
This episode is brought to you by our friends at Incident.io. Every software team on the planet has to manage incidents, and a very large percentage of those teams are using Slack to communicate. That includes us. With Incident.io, you can create, manage, and resolve incidents directly inside Slack. Here's how it works. Head to Incident.io and sign up for free, then add it to your Slack. From there, you have a brand new incidents channel where all incidents get announced. Use the /incident command to create and manage incidents. This command lets you share updates, assign roles, set important links, and more, all without ever leaving the incident channel. Each incident gets their own Slack channel plus a high-res dashboard at Incident.io with the entire timeline from report to resolution. Get everyone on the same page from the moment they join the incident and help stakeholders stay in the loop. Add Incident.io to your Slack today and prove to yourself and your team that they have everything you need to streamline your incident management. Learn more and sign up for free at Incident.io. No credit card required. Again, Incident.io.
Let's talk a little bit about use cases. I'm interested in sort of understanding sort of really where the sweet spot is for eBPF programs. Like we've talked about sort of observability and sort of knowing when certain things happen. And Derek mentioned that this is sort of a very targeted kind of tool, right? So you already know what system calls you want to sort of get callbacks about, right? Other than cases where you're trying to get everything, right? Which I'm assuming is a very different approach to writing these kinds of programs than when as opposed to having something very targeted you're looking for, like, a file open or something like that, right? So I'm interested in sort of understanding the use cases a bit more. So I've heard things like observability, which seem like a good sort of a use case for this. I've heard troubleshooting, like networking. I've heard people writing up load balancers, which I'm like really interested in understanding how that works. What's the realm of problems that you sort of look to eBPF to sort of help you, and what kind of problems are you solving?
Sure. So the use case that I use it for most is security. So I help maintain this project called Tracy that hooks onto really just like hundreds of different events and tries to correlate all these things that are happening in the kernel to determine if there is some type of intrusion, some type of malware. It allows you to apply policy on top of that, do cool things like when programs or processes are executed, try and capture the binary that was actually run for later inspection. There's a whole lot of things that you could do security-wise. Observability, you can use it in production, BPF that is, you could use in production for determining the health of your web services. So you could attach to your network sockets or some type of networking mechanism. There's multiple that BPF works with to determine how many packets are being dropped or where are packets being routed, get a lot of information that way.
That level of observability that we're talking about here, this is something slightly different from these days, more common usage of the term, right? Observability and things like that. So when we think of observability, we're thinking, okay, I need a dashboard, I need like a honeycomb or a Datadog or whatever it is, right? I'm like watching my services, are they up, are they down? Like what's the latency, that kind of thing. So what we're talking about here is like a different kind of observability, like a much lower level, yes?
Yeah, certainly. Like you have access to raw memory in most of these cases, or all of these cases, really. Like you could see the full contents of the packet or full contents of memory from a user space program. But you still have that, even if you're not inspecting memory, you could still just have these BPF programs trigger and just say, hey, this happened, in the same way as, if you were to add a line of code to your Go program and then recompile it and run it, like let's say a print line, you could, instead of recompiling or editing source code and recompiling it, you can add a BPF program attached to a certain space in memory and find out when like that certain line executes. And that's what delve does.
Yeah. So like, do we have to write all of these things ourselves, or are there not already like some tools around that we could use? Like, are there any tools that do like monitoring memory allocation, say, so, and collecting that in Prometheus so we can put that in a dashboard or something? Are there existing tools that are springing up around this? Is there like an ecosystem?
Yeah, I know that like there's a range, like from the sysadmin's perspective, like Brendan Gregg, who I know Grant mentioned earlier, he's like from Netflix, like DevOps extraordinaire. He has like a whole suite of like eBPF based tools and scripts and kind of one-liners that you can use to like inspect your system. I think he has, I can't remember if this is explicitly wrapped up into it, but he has a great blog post of like what to do within like the first 5 minutes or something like that of like debugging a production issue. And it goes through all of these scripts and tools and stuff that you can use. And a lot of them are eBPF based. But I think like the question that you were kind of alluding to was like the productization of this and like feeding this into like metrics gathering systems and things like that. And I know there's a lot of efforts in that space right now.
Yeah, it's interesting. So when you talk about running these things in prod, is this something that you have to do ahead of time? You have to plan, enable it, build things for it, or can you just go in and attach them to running processes? I mean, is you literally, because it's in the kernel, is it sort of almost underneath all the processes?
Yeah, I think like the most of the prep work is like ensuring that you have a kernel that can load these programs. And I think like as long as you're running on any kind of modern kernel, you're going to be fine. But in terms of like you don't need any coordination from like the user space program or anything like that. Really, all you need to do is coordinate with the kernel and get whatever program that you're running that is trying to do the inspection onto that production server to load the eBPF programs or whatever. But there's no coordination needed with the program. It's like from the perspective of like Delve or something like that, it's similar to like a normal kind of debug session where we just kind of ask the kernel for permission to do things in the user space program, whatever program we're inspecting, it's just kind of happening to it, but it doesn't really get to decide.
Yeah, that's interesting then. So that is quite useful for particularly debugging, but any sort of inspection on things, you could almost not be running anything. Like it's not like you have to run extra things to enable it. So I can see why a little collection of one-liners has built up actually, because that is quite, I suppose, quite useful to have those in your toolbox. Yeah, it's very interesting. We'll try and find that and put a link to it in the show notes. That sounds very interesting. And at least we'll be able to see some real examples of what eBPF programs look like.
Yeah. I would even add on, and relating to the last question about, what the ecosystem is like, I would say that you really don't have to, if this is a technology that excites you, or I should say having this level of visibility excites you, but you're perhaps intimidated or don't even want to bother writing this eBPF code, there is certainly like a developing, maturing ecosystem around this. Like there's a lot of products that are being developed for gaining that kind of visibility. And then follow up to that is that, yeah, like you don't have to recompile your code at all, which is good for like, I think a lot of the use cases for eBPF applies to perhaps like SREs or security folks, and maybe not, let's say if you're like a backend web developer, you might not be as interested in writing the eBPF code. But certainly like if you're an SRE and you have this running service that you're trying to figure out what's going on, being able to write a BPF program that inspects different areas of memory on the fly and being able to iterate on the BPF program without restarting your service is something that's really valuable and something that you can get a lot of advantage of.
Yeah, what about kind of higher level slightly than that? What about like, could you implement like a file watcher using this if you had to say something that was going to auto reload if you were a web developer? Could you write an eBPF program that would notice when files have changed in a certain path and then take some action, alert you somehow so you can refresh?
Yeah, absolutely. And I think Derek hit the nail on the head that, yeah, Brendan Gregg has a lot of tools for doing like very specific things really well. Like I think there's a tool called OpenSnoop that will just tell you every time you just run it, and it'll tell you every time a file is opened and get some information about it. Mm-hmm. And perhaps more robust, I guess, again, plugging the product I work on, but I really believe in it, is that Tracy, you could just run it and get all this information that you want and filter different events without ever having to write eBPF code.
And that's Tracy, Tracee, isn't it?
Exactly, yeah. It's under Aqua Security's GitHub.
So as a side note, you work with Liz Rice, right?
I used to. She left right after I joined, unfortunately.
I was going to ask you, what's it like to work with a rock star? Oh, I use a touchy term, with a well-known and respected member of our community.
Who plays rock.
It was fantastic while it lasted. I will say that. But I still interact with her plenty in the community. She does a lot for the eBPF community. So still get to interact with her.
Did you say that she left just after you or just before?
Just after. I scared her away, maybe.
Suspicious. Well, it's an option. It's possible, isn't it? That's what I was thinking.
Johnny, you had mentioned being curious about the eBPF based load balancing stuff that I had brought up earlier. I know Liz Rice gave a really good talk about kind of how to implement one of those. So if you're curious, I would definitely recommend seeking out her talk on the subject because it's really, really good.
Will do. Thank you. Yeah.
Cool. We'll also find it and put it in the show notes.
There is a great community around eBPF. Mm-hmm. There's a lot to learn. There's a lot to be confused about. The ecosystem is really evolving and becoming a lot more accessible. But there's a lot of people who are excited about it, who are willing to help. If you go to eBPF.io, there's a Slack channel that you can join that is very helpful. There's a lot of talks coming out. Derek and I are speaking at a conference coming up soon. There's a lot of material to learn from.
Yeah. And where is the community? Is it mainly hang out in that Slack channel then? Where else does this eBPF community exist for anyone that wants to sort of get involved?
I think a lot of the eBPF space and the technology in general is really big in the cloud native, CNCF land, cloud native, Kubernetes type ecosystem. That's, I think, where a lot of the community hangs out. And then it kind of dips into programming language communities a little bit for people who want to implement things and stuff like that. But yeah, a lot of the interest in a lot of the community is in cloud native land.
Much of the body of examples I've seen out there in my short looking into eBPF seems to be around BCC and Python land or something. I'm wondering, and I've seen examples of that. I'm wondering, when I saw that, I was like, okay, so we're writing some Python here, Python there. In the middle somewhere, we've got this giant string of C. and we can see where the hooks are, but it's okay, which kind of harkens back to the developer experience I was talking about earlier. I'm wondering, what is it like to write these kinds of programs in Go? What libraries is your go-to, in the Go ecosystem for interacting with and writing these kinds of programs?
I'll steal this one for a second. I'll also evangelize the libbpf Go framework because that's what I'm using in Delve to implement the eBPF-based tracing backend. So there's a lot of good tooling and stuff like that for writing and loading eBPF programs and using them against Go. There is some trickiness with certain features of eBPF and combining that with Go. To circle back, since this is Go Time podcast. So for example, and not to hijack the question or whatever, but just some of the trickiness that you might run into if you're using probes or whatever with a Go program is there's two kinds of probes. There's U probes, of user space probes. There's U probes and U rep probes. So U probes you can attach to the entry point of a function, and then U rep probes attached to the return of the function. So you can kind of see a function entry, and then when the function returns, you can kind of hook into both of those spots. But this gets really tricky with Go because the way that U-rep probes work is they actually modify some of the data, some of the addresses on a Go routine stack or a thread stack. So if you're not familiar, Go routines start with very, very small stacks, and they get kind of grown over time. And as part of that growing, the Go runtime needs to kind of look through the stack and look through what pointers are there and move them and do all kinds of updating and stuff like that. So if you're not careful with U-rep probes, you can blow up a Go program because when it tries to copy the stack, it's going to look through stuff and see an address that it has no idea about, and it'll just panic. So in Delve, we had to do some really kind of tricky stuff to use ptrace to like see when the Go runtime was going to copy a stack, and then like detach a rep probe, let it do its thing, and then reattach it. So there's like a little bit of hand holding there when it comes to the Go runtime. Like, so there's some kind of weirdness and wonkiness for like languages that have runtimes, or like self-introspective languages that could be weird with urep probes and doing this kind of low level probing that you might need to be aware of if you're like experimenting with this kind of stuff.
Yeah, that would be an unusual panic to encounter, I'm sure. So if you do have, say, you've got a little eBPF program that's going to it's going to somehow emit some interesting information, whatever that is, let's say just literally counting like allocations or something like that, then how do you get that information out? Where do you store it in the first place? Like, does the eBPF program have any memory? And how would the Go program get that information?
Sure. So yeah, perhaps the thing that we've missed when talking about BPF programs is like, what are the things that BPF program can actually do? So one of the main things that BPF programs are interacting with are various forms of maps. In the same way that you have a map in Go, you have various different types of maps that you can use to store information. And you could have a map that is shared between user space and kernel space, or the BPF program itself, or multiple BPF programs sharing this map in memory. So you could have something like a ring buffer that lets you, let's say if you have a simple BPF program that is triggered every time a certain function is called, or let's say a system call, every time a system call is triggered. In that BPF program, you can just have a little message that says, hey, the system call was triggered. Put that in, let's say, a string and send it to user space using this ring buffer. And then on the user space side, you just have a Go routine that is picking up these events and printing them to screen. So you have these buffers, these maps that you can use to share memory between user space and share memory between different BPF programs.
So do you literally get a channel interface then in the Go side where you can for each over or for range over the channel to just read this stuff?
So I'll say yes, but it depends on the library that you're using. Mm-hmm. So the actual underlying primitive is a different interface, but in the case of libbpf Go, you do have a channel. So you could really interact with it in the same way that you would like any other Go program.
Does that include sending stuff as well?
Sending is a little bit different because you're updating. There is an interface for it or an API for it for updating values in one of these shared maps. But the ring buffer is more for sending from BPF up to user space.
I see. So these maps then, they are literally like objects. They are key value pairs, basically. And does the kernel already have that concept? Is that already how it deals with things? Or is that something that eBPF models?
Without going into too much detail about the various different features, because there's quite a lot that, I certainly don't know about. eBPF, like the concept of having this visibility into the kernel is not new, but it makes things a lot easier. So before, something that you might have written a kernel module to do, something that doesn't have as many safety guarantees and requires you to restart or even sometimes recompile your Linux kernel and reload it and restart, and it takes forever. BPF, it does a lot faster, a lot safer, in a much more accessible way.
Yeah, but it does get quite exciting when you consider, as a Go programmer, being able to just have a channel where you're getting like very detailed information about what's going on in a system. Like, they're probably, like, even just that mechanism alone probably is enough to kind of spark a bit of innovation, I would have thought, in the Go community, because who knows what you could build. I mean, well, a file watcher was one thing that I thought of there, but I bet there's loads of things you can do if only you could get an insight into what's really going on in the kernel.
The possibilities are endless.
Yeah, getting quite excited about it. We've heard of libbpf Go quite thoroughly, and we'll definitely link to that. And I was looking at the repo, and it does look like a nice API. It's interesting. Even using this, could I end up in that situation we talked about earlier where I'm getting panics because should I avoid Go routines or something if I'm going to write code like this?
Probably the only thing that I would avoid if you're going to do anything with eBPF and Go is avoid urep probes unless you really, really know what you're doing, because it will almost 100% of the time crash your program. The only way to really make it work is to do this weird thing that we're doing in Delve that's kind of like a gnarly little hack.
Could that be put into a package? Could that little hack be solved once?
It's possible. I mean, it's solved right now in a way on a pending pull request in Delve. There's a lot that goes into implementing this workaround. It's some knowledge of dwarf, which is like debug info that goes into binaries, knowledge like using ptrace and having permission to use ptrace on top of eBPF. There's a few kind of things that are stacked that are like esoteric and non-standard for like a typical Go programming adventure. So there's some dragons there for sure. But yeah, I would say that everything else is pretty safe to use with Go, but urep probes are going to blow things up.
And what would they be used for?
Capture and returns from functions, return values.
Yeah, I see. But so if you're reading, if it's one-way data, use something like a ring buffer or something.
Yeah, from within like a program. So like the U probe will fire and start executing your eBPF program, and then your eBPF program can use like a ring buffer or a map or something like that to communicate back with user space. Delve uses both, so it kind of uses maps to communicate from user space to the eBPF program, and then it uses ring buffers for the eBPF program to send data back out to Delve.
Yeah, see. It's really interesting when I think of like Delve, I see that as a very sort of low level tool because I work on like bigger systems. They're the sort of systems that I think of. So, but it's always interesting to me when I zoom in down, you get these same kinds of layers. There's this same, often more complicated sort of little architectures around. I always find that to be quite fascinating, really.
Simple is not easy, man.
Yeah, absolutely.
What's going on, Gophers? This episode is brought to you by Equinix Metal. If you want the choice and control of hardware with low overhead and the developer experience of the cloud, you need to check out Equinix Metal. Deploy in minutes across 18 global locations from Silicon Valley to Sydney. Visit metal.equinix.com/justaddmetal and receive $100 in credit to play with. Again, metal.equinix.com/justaddmetal.
Well, I was going to ask, what do you think's like going to be the future for eBPF? I mean, do we feel like this is the start of something that's just going to keep getting more and more exciting?
Commercial products. That's what's next. Commercial products.
Is that what's going to happen next? Let's start the company now, us four. Let's just do it live on the Go Time. Not the Go Time, is it? It's Go Time. I've done the thing about the Facebook. I think it's cooler though. Like, I think that was very much of its time, taking the off Facebook. Mm-hmm. I think it's cooler now to be called like the Go Time.
The Go Time.
Like, you know what I mean? I feel like we've gone all the way around there.
Mm-hmm.
But what would a company look like if we were going to start it?
I would definitely say that the ecosystem is very, very much maturing, or I should say just starting to mature, but there's really so many use cases that haven't been tapped yet. LibBPF hasn't even hit 1.0 yet. I think a lot of people are entering the community who are just learning about BPF. So there's a lot of talk on the kernel side about BPF eating Linux, about rewriting large swaths of the Linux kernel in BPF code to make it much more module. So I certainly think, like one area is like the scheduler, for example, being able to put logic into the scheduler on the fly for changing how we schedule processes. Certainly like drivers is another concept that people are thinking about. But really at like a high level, I don't want to go to like thought leader on
please do
on all of you, but
please do.
I think that I forgot who gave this talk or talked about this in a presentation about how BPF sort of represents this new paradigm of software that gives you the ability to change the way your software interacts with the operating system on the fly. it's hard to say where BPF will go because one, there's like a million more ideas for what you could attach BPF programs to. Two, there's so many people like entering the community that are coming up with really good ideas. There's a lot of new contributors and whatnot. And really there's not much restriction on those ideas. It's like saying, what's the next big thing for Go, or like that you could write in Go? Really anything, except maybe BPF is cooler.
Okay, well, that brings us to our regular segment. It's time for Unpopular Opinions.
I actually think you should probably leave.
Grant Seltzer, do you have an unpopular opinion for us?
So I do. Mm-hmm. I would also like to mention that I am the reigning champion of unpopular opinions.
Oh,
is that right?
I have the most unpopular opinion of all time on the show.
Yes, when you said eBPF was cooler than Go.
Oh.
You beat your own record then.
I think I said something about baseball.
You'd like to switch your unpopular opinion?
No, I still agree that baseball is the best sport, but I won't try and beat that. I'm not going to say anything political or anything. I would say that something that I've always felt is that engineering organizations should have a security engineer on every team.
Really?
I think there's a lot of decisions that software developers make, or even at a higher level, like people who are architecting entire systems, that the input of a security engineer or someone, even a software engineer who has more training or will think about things from a security perspective, can be crucial to making an entire organization more secure, as opposed to having a team on the side of security engineers that are just trying to throw products at already existing infrastructure.
So this is, in your mind, different from having some sort of a security review before you ship a version of the product or something like that. This is more like having somebody as part of the team as you build software.
Yes.
Yeah, so is this a little bit like how testing used to almost be a separate concern to software engineering, and then we sort of became test-driven developers, and we sort of realized that was our responsibility, was to write well-tested code. Are we headed for SDD, software security? Sorry.
What are we talking about here, Matt?
Are we getting towards more like SDD, sort of like security-driven development thing?
SDT. Oh, I thought you were talking about something else.
No, driven development. DD.
Gotcha.
That's so difficult to do for some reason. Write it down.
Mm-hmm.
I think I did it. I think we can get it in the edit. I'm happy to move on if everyone else is.
That would be ideal. It's
definitely true when you're designing systems that security is one of the key things that you think of. And you're right. Like, sometimes you can just make design decisions that make systems more robust, like if they're idempotent, so that you can just retry something lots of times and kind of better safe than sorry, because you've designed it a certain way. It's not gonna break. And you can do that same thing with security issues too. You can just by making certain design choices, you're sort of necessarily more secure. So yeah, I think interesting one. We're going to definitely test that one on Twitter. We would test it on Facebook, but I think we all know why that we're not gonna do that.
Ayo.
We'll never see the results.
BGP different from BPF.
Oh, is it? That's why we did the show. Oh no.
It was timely. It was timely disambiguation. Yes, indeed.
I made a mistake. Okay, very well. Well, very interesting. What do you think of that, Johnny? What do you think about having a security person on the team?
I don't disagree. It's hard to disagree with that.
To be honest, though, it's hard to disagree when anyone says anything about security. You can't be the person in the room saying, no, I think we should be less secure. Derek, do you have an unpopular opinion for us today?
I do. I didn't last time. I choked, but I have one this time. It's less thought-provoking than Grant's.
It's less dramatic as well if you're not choking. Like, if you can't feel your anxiety. That's where the drama comes from in this segment.
So from going back and forth to like writing the Go stuff and then switching to like the eBPF stuff, which is bringing me back to a lot of C. My unpopular opinion is snake case is better than camel case.
Whoa.
So for anyone not familiar, what's the difference?
So snake case is like word underscore another word underscore another word, where camel case is like word, then uppercase, first letter, another word, uppercase, So Go version versus what you would typically see in like C or Rust or something else like that. I just think snake case is so much more, it looks nicer. It's more readable. I don't know. It's not just like a jumble, like all words just kind of jumble together. It's like, it almost looks like a sentence or whatever, I don't know. It just looks nicer to me.
Mm-hmm. Yeah, very interesting. What about hashtags on Twitter? Do you do snake case hashtags?
I just go all lowercase. Yeah, strings to lower. And then I write my...
Strings to lower.
Yeah.
Yeah, do you do that with eBPF, do you? You attached to that somehow. Change it before it tweets out. Apparently, it's an accessibility problem though, doing all lowercase, because it's hard for screen readers to do it. Like they just say really. I used to do it deliberately on my computer. I'd just put in loads of nonsense and make the computers try and speak it. It had hours of fun.
Yeah.
Yeah, it's like fuzzing the say command basically.
There's endless amounts of fun SSHing into somebody's computer and then writing say and then some random stuff.
Oh yes. Oh yes.
But typically, I try to stick with one word hashtag, so hopefully I'm not messing up with any readability stuff.
No, but snake case would fix it. Snake case hashtags would fix that, wouldn't it?
There you go. Yeah.
It would look suspicious, but yeah.
It would look strange, but I used to do Ruby, and that was the standard in Ruby. You would just write with little snake case things like underlining. Yeah, I don't know.
As they say, when in Rome, do as the Romans.
There was a very interesting talk at GopherCon one year about writing Go code, or perhaps code in general, that is more accessible. And part of that was making it easier for a screen reader to read. And I was thinking about that when Derek said that opinion. I feel like it might be easier for screen readers, snake case versus camel case.
Yeah, it may be. I don't know. But Derek, how far does it go? Like, would you name your kids with the snake case names?
You still thinking about this?
Yeah, they are. There's no spaces. It's my youngest is Davey underscore.
I can't wait to meet the first engineer that does actually call their kid something like underscore, something like that. I would love it. That's a good one then. So, Johnny, are you sold on that?
I'd say if I've done some Ruby, so I'm like, yeah, I'm very familiar with the readability of the underscore. But yeah, since this is a Go Time podcast and we're talking about Go, I'm gonna say no, I do not like that opinion.
But Derek, do you write Go code with underscores?
No,
do you actually do that in Go code?
No, I'm not a monster.
He knows better.
What would it look like? How bad is it?
I think where it falls apart for me is uppercase snake case just seems really wrong to me. So it doesn't work for me in Go because capitalizing to export, like a capital first snake case statement, that's just wrong. That's wrong.
Yeah, it all looks wrong until it just becomes the way we do it.
Right.
It's just all trendy. There's nothing wrong with it at all. I'm going to do it now and see what it looks like. Yeah, I feel sick. It's awful. You're right. Yeah. Oh, that's a good one, that. I like those ones. Johnny, have you got an unpopular opinion these days?
My unpopular opinion is that I can never come up with an unpopular opinion.
Yeah, I know, because you're too popular.
It's like every opinion ends up being popular. So I'm sick and tired of having unpopular opinions because they're always popular.
That's very meta. Your unpopular opinion seems to be we shouldn't keep doing this segment. It's funny because when we put them on Twitter, I genuinely think Grant is the record breaker because most of the time people just agree. The case that's made is just well made very often.
Now, these days, what I look for is what's the ratio of people who disagree, right? So I'm trying to figure out how many people actually do lean one way or the other. That's more interesting now than trying to say, oh, this is overwhelmingly unpopular, right? Because that doesn't happen often.
Yeah, no, it doesn't. It's very interesting. Well, we're coming to the end. I just want to do a quick shout out. It's like a shout out, but the first time I did it, I said it wrong.
Yeah, you're shouting at.
So now it's a shout at.
Okay.
And we're just going to shout at a particular meetup from about the place. Actually, today I'm shouting at the GDN page on meetup.com. So it's meetup.com/pro/go. And that will give you a great list of resources, local meetups, places, people around you, gophers that you can go and meet and talk to. And who knows, you might find someone there that's interested in eBPF, and then you can talk to them about it and join in, see if you can build something cool.
And for those who don't know, GDN stands for the Go Developer Network. So this is sort of the meta organization behind all of the Go meetups and events and even things like Go Bridge and things like that. So that is the behind the scenes of the behind the scenes.
Yeah, and it has a lot of members. 117,000 members at the time of recording. So you could be one of those ones, or you can't, or you already have to have been one of those, but you can increase the number and be that one.
Yeah, and definitely join the GDN, and we'll send you your license information in the mail for having joined the Go Developer Network. I'm kidding. There's no license.
I was getting excited. I was thinking I'll join this.
We're not a licensing organization.
Oh, what's the point? I want to do it. If I don't get a badge,
You want to get a certificate?
little silver gopher, that you can just flash it at certain places and you get half off.
I can DM you my address. You can send me a check.
Okay, and you're going to make me a little gopher police badge.
Yeah, I'll make you a doodle and I'll send that back to you.
You say Sheriff Matt on it. Yeah,
You can be a sheriff, man. You can be a sheriff.
you should have that. You should have like ranks in the force.
In the force? Where are we?
Yeah, it's like a police force now.
The Go Developer Force, right?
Yeah, it's like a government agency now. It's like Matt Ryan, GDN. Oh no, it sounds like a news organization. Is that the homepage for it then, Johnny? You seem to know a lot about this.
Yeah, that is the starter page.
How do you know so much about it?
Oh, I know some people who know some people.
It does sound like a dodgy organization. I know some people. They know some people. It's like, that's a nice GitHub handle you've got there. It'd be a shame if anything were to happen to it. That is all the time we have today. I hope you enjoyed this deep dive on eBPF. Very technical and very interesting and quite exciting. I do want to see what gophers are going to build with it. I think there's some exciting opportunities there. Tweet us at GoTimeFM if you build something cool with it. We'd love to hear about it. Thank you so much to our guests today, Derek Parker, Grant Seltzer. Always a pleasure. You'll have to come back. And of course, Johnny Bosico was here. And so was I. I've said me. See you later. Bye. Not the most professional ending I've ever done. But there we go. And now we have to play the outro.
Yes.
Goodbye.
All right, that is our show for this week. Thanks for listening. Good news, we just restocked the GoTime merch, so you can rep your favorite podcast with a comfy tee. Check it out. We probably have your size now at gotime.fm/merch. GoTime is produced by Jared Santo, that's me, with music by Breakmaster Cylinder, that's not me. We are brought to you by Fastly, Launch Darkly, and Linode. Next episode, Chris continues our series on maintenance. This one's about maintaining ourselves in the fast-moving software industry. That's what's coming up next time on GoTime.
But that's probably the end of the podcast.
That's how the sausage gets made. Oh, our live viewers.
like it was dead cool. I love that mic drop. I love the unnecessary mic drop. That's what you've just invented, Johnny. You're like, and that's how the sausage gets made. That's really cool. I'm going to do that. I'm going to do that at the end of every meeting that I have at work now. Yeah. And that's how the sausage gets made.
Then storm out.
I'm just trying to find the right window to click end on. It's not a very elegant exit.